everyone. Can you hear me? All right, cool. I'm gonna get started. Sorry, this thing's like a little weird. So welcome to my talk, in-depth path morphing with shapeshifter. My name is Alex Lockwood. There's my Twitter handle, AlexJLockwood. I'm an Android developer at Lyft. You can find the slides for this talk at j.mp/pathmorph. They're also posted on my Twitter, in case you miss it. So I actually think it's really awesome that my talk came basically right after Stacy's, because while Stacy talked a lot about, a bunch of different ways to do animations on Android, this talk is going to be really focused on a really small, obscure animation technique called path morphing. Stacy also mentioned a tool that I'm going to be talking about, shapeshifter, in one of her slides, which I'll get to a little later. And when I think of path morphing, I think of these as kind of the classic examples. On your left, there's the Pocket Casts app, and on the right, Timely Alarm Clock app. And as you can see, unlike traditional animations that animate rotation, scale, alpha, numeric values, colors, path morphing animations are unique in that they're actually transforming the object's shape over time. And it's hard to wrap your mind around how it actually works at first. And for me, personally, I remember, the first time I kind of understood how it works, I was reading some blog post posted by somebody at Mozilla, and it was kind of like a mind-blowing moment. And I hope by the end of this talk, you'll have a better understanding of how it works. So path morphing isn't at all specific to Android. It's actually much more common on the web because it's been supported much longer. This is an NPR article on gerrymandering in North Carolina. It's being rendered in Chrome and animated using SVGs in a JavaScript library called D3. As you can see here, it's really has a nice visual effect here because it's kind of using time as a third dimension to, compare the before and after states of, the district boundaries. You can technically do this in Android as well using animated vector drawables. Hopefully you could even use shapeshifter to create something like this. But again, I'll get to that a little later. And as a sort of extreme example of what you can do with path morphing, this is, animation obviously written by, a professional designer using After Effects. Stacy also mentioned a library that you can use to transform After Effects into native animations using a library called Body. And you can't really tell how this is actually working if you look at it, but under the hood, it's being expressed using hundreds of paths, and each path is being morphed in different ways in different directions over time to create this really cool visual effect. And again, this isn't even specific to web or Android necessarily. It's also the type of stuff that you see in video games or TV commercials. So before I go much further, I just want to give a brief overview of how path morphing works in order to understand how to animate an object's shape. You have to know how to draw it. And to do that, we use something called the SVG path data spec, which is basically, you can think of it as a virtual pen floating on top of a canvas, and it's expressed as a string, and essentially what that string gives you is a sequence of drawing commands. So this first command is a move to command. It just moves the pen to a certain coordinate. The L command is a line to command. So you're just drawing a line to 9,6. You draw another line, and another line. And there's your shape. Obviously, it's a really simple example. You can also draw curves using the SVG path data spec. Using the C command, which I'll talk about a little bit in this talk. And there are are a few other commands like Q's and T's for quadratic Bezier curves, and elliptical arcs is an A command, but I won't focus on that as much in this talk, just to keep things simple. So say you want to morph that square into another shape. You can do that using the familiar object animator object, which Stacy also talked about. This is animating the path data property of a vector drawable path. And the obvious question here is, how does this even work? Like, if an object animator is responsible for generating the in-between states of an animation, how do you go from these two arbitrary looking strings? If you're animating like a float or if you're animating like rotation, for example, it's easy to understand how the animation will work, right? It'll just go like 0 degrees, 1 degree, 2 degree, and it'll redraw on every frame and give this illusion of continuous movement. But how do you go from these two strings is sort of the question we have to answer. And easy way to visualize it is if you line the paths up vertically and you go through each pair of points and you ask the question, what's halfway between these 2 points? In this case, it's 12.3. You just go pair by pair, and once you get all the way through, you have this intermediate SVG path data string. It should be obvious here that one of the requirements then is that both path strings need to have the same number of points and same type of commands, otherwise this strategy doesn't work. Here's a visual example of what that exact object animator was doing. You have a square on the left and a square on the right, and as when you play the animation, you can see it's just sort of translating from one position to another. It looks like a translation animation, but it's actually, on each frame it's generating this new SVG path string, redrawing, and giving this illusion that it's translating from one location to another. And if there's one thing you should take away from this talk, really, it's that path morphing animations are really just moving path points. So you can see here that each point is just literally following a straight line to its end location. And on each frame, the computer calculates the new position of the point and then recreates the shape, and frame by frame it creates this really cool transformation looking animation. We start to run into some trouble though when the number of points on both sides aren't equal, right? Like how do you animate 4 points to 8 points? You can see that now all of a sudden you have 4 points on the left and 8 points on the right. And what does it do with these 4 points? If you tried to morph these two on the web, it would look something like this, which is obviously not what you want at all. It gives this weird like inverting in on itself type appearance, and it just looks really messy. On Android, it doesn't even let you get that far; it just throws an exception, which it's probably actually better in my opinion that it just throws an exception, because really it doesn't make sense to morph between two shapes with different numbers of points, right? It's going to give you undefined behavior, either way. So how do we fix this? We fix this, obviously, by using what I call the Undercover octagon. And what I mean by that is we can transform that square into an octagon that still looks like a square by inserting these dummy points, right? And this is just for the purposes of animation. It still looks like a square, but the computer sees it as an octagon. And now when you morph it, it looks, just as you would want it to look, right? I should point out, though, that it's not often that, shapes have the same number of points. So this is like a really important strategy, because it sort of just happens by chance when you have two, arbitrary shapes that just happen to have the same number of points. So we talked about morphing lines, but what about curves? And you might think this is a much more complicated problem, but if we draw it out like this, it actually becomes, pretty simple. We have two cubic Bezier curves, and we can express it by their endpoints and two control points. And once you draw it out like this, you can see that we're just treating it the same as a line. We're just translating the points to their new location and issuing a redrawn command. We run into trouble though if we try to morph a line into a curve, right? How do you solve this? And we can use a trick here by expressing that line as sort of like an undercover curve. It's a curve that looks like a line. If you place the control points of the Bezier curve along the line that connects the endpoints, it looks like a line. And now you can get a seamless looking morph like this. Taking it a step further, if you want to morph a octagon into a circle, you could apply this strategy and just transform all the lines into undercover curves. And now you get a really smooth looking animation like this. So again, this is not at all obvious, but it's actually, path morphing actually is pretty simple under the hood in terms of how it actually works. There's a second problem we need to solve though, and that is that the order of the points matters. It's not going to crash your app, but it will have dramatic effects on the appearance of the actual animation. And what I mean by that is, earlier we morphed a square into an octagon. The top point is the first point, and both are counterclockwise. But now what happens when we shift the order of the points over? You can see now the 8 is at the top in the octagon. And now you get an animation that looks like this, right? It may or may not be what you actually want. Even worse though is when the point order is reversed. So in this case, the order of the points in the square is clockwise and counterclockwise in the octagon. And now you get something that you almost certainly don't want, where it just sort of inverts on itself. And again, like there may be cases where you want this, but it probably won't be the case most of the time. So to recap, the two paths you're dealing with need to have the same number of points and same type of drawing commands. Otherwise, the object animator won't understand how to create those intermediate states. We can use this strategy of adding dummy points and converting lines into curves, though, to alleviate this. And the order of the points matters a lot. It won't crash your app, but it will, decide what the actual animation ends up looking like. So before I go further with this, I just want to talk about, what actually got me interested in this subject to begin with. It all started with a blog post I wrote about animating icons. And it just sort of went through all the different ways that you can animate, whatever icon you want into, basically just all the different ways that you can animate animated vector drawables, I guess. And I was really proud of it, and it took me a while to write, but I came out of it kind of feeling bittersweet about it because it was just so hard to write the path morphing animations. I ended up having to, basically do all this trigonometry stuff in order to learn how to split Bezier curves and in order to add dummy points, and it was really complicated, and it almost wasn't even worth it at that point. And I felt like I was putting out this blog post saying, you should use animated icons because they're really cool, and kind of knowing in the back of my head that it was really challenging. Around the same time, Nick Butcher put out this blog post where he created this really cool pin animation. The bottom, it's just translating a path, but the top part of it is actually a path morphing animation. I think it's animating between like 5 different paths in order to create this effect. And we got together and we sort of agreed like it was way too hard to create these, and we got together, we sort of like went through like what were all the problems that we were facing when we were creating these animations, like why was it taking so long? And we agreed kind of that it was mostly a problem with tooling. And when designers give us assets, they don't care, the order of the points. They just care about, do the assets look the way that we want them to? Tools like Illustrator and Sketch probably aren't going to expose ways to reverse the order of the points or shift the order of the points, because what designer would ever need that functionality, right? We also found it difficult to create dummy points. In a lot of cases, you want to overlap dummy points on top of each other, and we found that design tools generally don't allow this. They allow you to create a dummy point that's like really, really, really close to an existing point, but not exactly on top, which again makes sense if you're a designer, because why would you ever want to do that? But it makes path morphing animations really difficult to create. And lastly, it was really difficult to visualize what the path morphing animation looked like, throughout the animation. We wanted a way to just, quickly visualize what this morph will look like, and we didn't want to have to like install a sample app over and over and over again, and go into the system settings to like slow down the duration, and go through all this stuff just to visualize what it looks like in those in-between states. Because as I said earlier, the point order is going to really determine what those look like, and it's really important to perfect that if you want to get a smooth looking animation. So we sort of started thinking, what if there was a tool that could allow you to do all these things? It could allow you to create dummy points. It could automatically convert lines into curves without you even, worrying about it. It could allow you to reorder the points, whether it is, shuffling them or shifting them or reversing them or whatever. And then finally, just export them all to SVG vector drawable or animated vector drawable. And this is really how the idea of Shapeshifter was born, which is a tool that I wrote just to sort of solve all of these problems and make it really easy to create path morphing animations. And I'm going to go through a quick demo of creating a plus to minus path morphing animation. So you can see here, I just dragged 2 SVGs into the web app. There's a plus and a minus SVG. What I'm going to do now is I'm going to create a path data property tween. You can see that little rectangle on the timeline is you can think of it, I guess, as the object animator that's animating the vector drawable path. So I'm going to copy the minus SVG path into this 2 value, and you can see now that stuff becomes red because the paths aren't compatible, right? The plus has 12 points, or what, 16 points? Yeah, 16 points, and the minus has 4. So the object animator is going to crash your app if you even attempt to do this. And you can also see that there is that little magic wand. Sorry, I paused it a little late. That's going to suggest, it's going to try and automatically fix everything, but I'll get to that a little later. So as you can see, there are 16 points on the, sorry, that's 16, 12, however many points, and 4 points on the right. So what I'm going to do is I'm going to use this little plus icon up here in order to create dummy points, and I'm just going to add 8 without really caring where they are. And you can see now once I've added 8, it will suddenly become blue, and that's because now the object animator isn't going to crash. And again, because the point order matters a lot, it's going to look really bad. And that's because if you look, you can see that the order of the points is reversed, right? One is in clockwise and the other is counterclockwise. So I'm going to use this, no, sorry, actually I'm going to shift them first. And yeah, so now they're both in the bottom right. It still looks bad because they are in the wrong orientation. And now I'm going to use this reverse points tool that will get everything, get all the, the orientations matching and stuff. And now what I'm going to do is I'm going to just move the dummy points to where I want them. In this case, I want 2 points to animate to the top of the plus and 2 points to animate to the bottom. And now once I do that, I get something that looks like this, which is what I finally wanted. Again, I mean, in this case, it probably wouldn't have been too difficult to write this out by hand because we're just dealing with, with lines, and the shapes are pretty similar. But as you can see, there are much more complicated examples that we also need that we're also more likely to encounter. In this case, what if I wanted to animate an arrow into this overflow icon? And unlike before, now we have to deal with the fact that we need to morph 3 shapes into 3 shapes. And we can't do that in this current state because the design tool probably exported that arrow as one shape. And what we can do to create this animation then is we can basically slice up that arrow into 3 separate shapes in ways that, it will still look like an arrow, but it's actually being expressed as 3 separate subpaths. And you can see up here, there's this little scissors icon that allows you to draw lines across the shape and tell it how you want it to split the arrow apart. It also allows, you can also use this pair subpaths tool to, tell it which shapes should animate to what. So in this case, I just want the top part of the arrow to animate to the top part of the overflow icon, and, and so on. Once I do that, I find that the paths aren't compatible, and that's because the overflow middle circle has 4 points and the arrow has 7. So I need to add 3 new points, and once I do that, it will look just the way I want. Yeah, thank you. But to make it a little nicer looking, I'm going to add a little rotation to it. So what I've done is I've created this group layer, and I'm going to set the pivot to 12, so it's pivoting across the center. And I'm going to create a rotation animation and rotate that the entire thing 360 degrees while the path morphing animation is playing. And I find this strategy to be really useful with path morphing animations because a lot of the times you can still kind of see how the path morphing is working, and you can't get it exactly perfect. But if you add rotation, it sort of distracts the eye away from it, and it, yes, thank you, GPU. So again, this would have taken forever if I had done it out by hand. And this is really what I sort of created the tool for. To give some examples of what the output looks like, it looks like this, but don't worry, I know it looks super complicated, but it's just something you drag into your resources and sort of forget about. This is an animated vector drawable. It is I think it's the animated vector drawable for the animation we just created. You can also export as an SVG sprite sheet if you happen to be a web developer, and I have a few other export options as well that I'm working on. And this is all available at shapeshifter.design, so check it out. Or you can, and if you missed this, it's in the slides. So yeah, and these are some examples that I created using Shapeshifter. As I was debugging the tool, I sort of my way of debugging it was I'd just pick random icons and figure out how I would morph them into each other. And these are some of the 6 that I came up with, and they're all pretty simple icons. And then I tried to do this, which we're not dealing with icons anymore. These are SVGs with hundreds of points, and even using shapeshifter, it wasn't super fast to create these, because you had to create 50 dummy points, add them, move them around, and while that process was pretty simple with icons containing 10 or 12 points, this dealing with like 100 points was it almost wasn't even helpful anymore. And that's when I sort of came about this idea of autofix, which is something I alluded to before. It's going to try and fix everything automatically for you. It's going to try and figure out the optimal position of the dummy points so that you don't have to worry about it. It's going to automatically convert everything over from lines to curves for you. And when I first started working on Shapeshifter, the goal was really not to be this automatic thing that does everything for you, because stuff like that already existed on the web, but there was always this 25% chance or so that the automated result didn't look the way you want. And I felt it was really important to make it possible to get exactly the animation that you wanted. But once I encountered that animal morph, I sort of thought, what if I could provide this autofix algorithm or whatever, and maybe I could use it to get it like a halfway where I want to be, right? Like I could use autofix to add all the points to the elephant or whatever, and if it didn't look perfect, I could maybe I only had to tweak a few points or something like that, and it would save me a bunch of time. So I sort of first thing I sort of did when I was designing this was I made this assumption that usually path morphing animations where the points travel the least look the best, and this is kind of a good example of that, right? Because on the far left, the points are traveling all the way across the canvas in order to get where you need to go. And since they're traveling such a far distance, there's a more likely chance that they're going to overlap on top of each other and create this really weird looking intermediate state. Compared to the one on the far right, where only 4 points are moving and everything else is just staying stationary. And this ended up being a really good assumption to make when starting out writing this. So I took a shot at first basic implementation. It's a 3-step process. The first one is you have your original shapes. The purple are the ones that you start with, and the green ones are dummy points that I'm adding. I found that adding a bunch of dummy points usually made the animation look a little better, I guess because it sort of reduced the variation of I guess it sort of normalized the intermediate states that you end up getting. And once you have 2 shapes with the same number of dummy points, you can test every orientation of points, and you can see it's sort of recalculating for each orientation of points. It's like calculating the total distance of points, and once you do that, you can just pick the orientation with the smallest distance, and you end up getting this, which is it's exactly what I wanted. Using this strategy with the elephants, it gives you something like this, and the pros are that it is a really natural looking animation. There's nothing really wrong with it visually, and the algorithm itself is super easy. It's just a 3-step process. You basically just have to go through every order of points, calculate the sum, and pick the smallest sum. There are some downsides though, and that is that, as you can see, there are like tons of points being added, way more than are probably necessary. And more dummy points means that the SVG path data strings are longer, which means larger APK sizes, more the runtime cost of parsing the XML files, the runtime cost of executing a ton of different commands unnecessarily. And lastly, it sort of defeated the purpose of what my original intention was, which was to make Shapeshifter easier to use, right? Like I'm adding all these dummy points, and if it doesn't look the way I want, then what I'm stuck with is a shape with way too many points, and I'm probably just going to have to delete all the points and just start over again. So what I needed was a way to, I guess, really just reduce the number of dummy points I'm dealing with. And so I went back to the drawing board, and I remembered a dynamic programming algorithm, I think I learned in college. It's used to align DNA sequences, which sounds random, but it'll make sense pretty soon, I promise. So what you can use this algorithm for is if you have two strands of DNA, right? DNA is made up of nucleotides with C's, A's, G's, and T's. You can run this through the algorithm, and it will output something like this. It'll tell you, how one DNA strand evolved into another over time. So like, for example, if, I guess this could be used to determine how closely related two species are, like how are they linked in evolution. You can also extend this algorithm by preferring pairings of certain nucleotides. So like if you wanted to prefer, pairings of C's and A's over C's and T's, for example, you can tell the algorithm to do that for you. Back to SVG path data strings though. Say you ran this through the algorithm. What would that actually mean? And what it means is that you can sort of treat the gaps in the alignment as dummy points that you need to add. So in this case, you're splitting that L, the command between the L and the C, into 3 commands. And there's one mismatched pair that you need to convert, one line that you need to convert into a curve that looks like a line. You can extend the algorithm in similar ways by preferring pairings of points that are close together, right? Because we want to minimize the amount of distance that points are traveling from one location to another. So doing all of that, you get something like this, which is exactly what I wanted. It doesn't add a ton of points unnecessarily. You can see that another thing I thought was really cool is that it's really smart in detecting, this algorithm is really smart in detecting areas where you need a lot of fine-grained details. So like, for example, that the ear of the hippo is transforming into the trunk of the elephant, right? But the elephant doesn't need this many points, but the hippo does in order to draw that fine-grained detailed curve. The downside, I guess, is that it's a little slower. The algorithm is O(n) squared as opposed to O(n), but since this is a compile time tool, it's not going to affect the runtime of the application, and I felt that was okay. And yeah, so this worked perfectly, and this is actually what's currently being used in Shapeshifter. Now, how do we deal with this problem? We morphed a circle into a star earlier, but how do you automate this, right? Because the circle has two paths now, two subpaths. It has one for the outer radius and one for the inner radius. And the star only has one outer path. So what do you do with that inner radius, I guess? And you can apply this sort of neat trick. Basically, what we can do is we can create a path inside the star that doesn't actually appear to you at all. It's just a ton of points, overlapped on top of each other, and it actually creates this really awesome effect of like being sucked into a black hole or something. So I found this to be a really useful way of dealing with, for example, I think if you automated the arrow to overflow icon using autofix, it would basically create two dummy paths in the arrow in order to, create that animation. Here's a much more complicated example that, I guess it kind of shows, when this effect isn't what you want, right? You have Texas, which you want to morph into Hawaii, and you have 7 extra shapes to deal with in the Hawaiian Islands. And basically what this is doing is, as you can see, it's sort of the Texas SVG is, or vector drawable, is being expressed using 8 paths just 7 of them aren't really visible to you. And when you're animating from and between the two, they just sort of, scale in and out. So the obvious question here was, is there a way to automate this? Like, is there a way to automate the splitting up of Texas into 8 shapes? You can use Shapeshifter to do this, obviously, by using that, split up tool that I mentioned. But how can you automate it? And so I went back to the drawing board with this, and I came across this concept called triangulation, which is a process that's like used a lot in low-level GPU programming. It's common in WebGL, where you want to display something like a really cool 3D effect, and in order to do that, you need to triangulate what you have and send all the triangles down to the GPU, because GPUs tend to only like to draw triangles. And so I applied this sort of logic to it. So let's say I have Texas and I want to triangulate it. It'll look like this. And there are way too many triangles, but that's okay, because the next step is to pick a triangle at random and merge it with one of its neighbors. So it's sort of like 99 triangles of beer, right? Like you start with a bunch and you just merge until you have the number of shapes you want. And that's what it ended up looking like, which is pretty nice in this case. This is probably, somewhat along the lines of what I would have done in Shapeshifter by manually splitting up the shape. Here's a totally gratuitous example of this algorithm in effect. I'm just sort of morphing random shapes into, random, I don't know, just, I guess the one thing that is sort of weird about this algorithm is that it tends to generate these long slivers, sort of like that, which it didn't work. Basically, it didn't work in all cases, and I wanted something that would work most of the time. So this didn't actually make it to Shapeshifter. I figured it's probably not too much trouble to just slice them up manually, and that's probably what you would want, in most cases anyway. But I don't know, I thought it was pretty cool. So that's all I have with most of this stuff. I wanted to end this talk just by talking about some stuff I've been working on. In Stacy's talk, she mentioned there's a learning curve to Shapeshifter, which, by the way, I totally agree with, and it keeps me up at night. So that's what I've been working on for the past, 6 or 7 months, where I'm basically trying to every time even I open up Shapeshifter, I expect it to be able to draw like this, and it's really frustrating when I remember you can't, because I didn't implement it. Yeah. But yeah, so this is something I've been working on. It's not all the way done. You can see there are a bunch of different tools. I think I even added rotation and transform tool since I made this video. It's actually been pretty fun for me to implement, because I've learned a lot about Sketch in the process and all of the keyboard shortcuts, and it's also a pretty challenging thing to work on, and not one that I feel like I'm even close to finishing. But I do want to sort of, I think this is actually the first time I even really announced this publicly. I think I've mentioned it to a few people, but you can try it out for yourself at beta.shapeshifter.design. I set up crash reporting so you can help me find crashes, which probably exist. And so this is something I work on a lot on the weekends and stuff. And you can check that there. And in closing, I sort of think of Shapeshifter as a really dumbed down version of After Effects. Like, if you're a designer and you happen to know After Effects, definitely use that. But most of us, developers especially, aren't familiar with design tools. This this animation took me a really long time to create just because, I mean, if you look at After Effects, there's just a ton of random unnecessary stuff. It's a tool that you use for like really complex video editing, graphic stuff, and icon animations are probably the simplest possible thing you can use to create with it. So I guess Shapeshifter has always been, in my mind, a dumbed down, like open source, free version of After Effects with only the necessary tools that you need in order to create these animations. And that's why I guess I'm so passionate about it, because I think it's really important for even developers to be, able to use design tools without, paying a $500 yearly subscription fee and, learning all this stuff on their own. So this is information about Shapeshifter. Shapeshifter.design is the URL. There's also beta.shapeshifter.design that I forgot to mention here. The GitHub repo, and I've also set up an open collective Shapeshifter page, which is basically a place where you can donate either one time or a small monthly donation or whatever. These are some people who have done that. My apologies for anybody I left out, because I think a few people should be added to this list that I didn't update. But if you go to the page, all their icons are there, and I plan on hopefully using that money to hire people to work on specific features. Actually, I think I hired the first person the other day to work on something pretty cool that I'm excited about. So there are the links. And special thanks to these three guys. I mentioned Nick Butcher, he's the developer advocate at Google. He kind of is the reason why I got so interested in animations. Roman Nurek, he's a design advocate on Firebase. You probably know him from his web apps such as Android Asset Studio. He helped me a lot with getting started with web development, because I didn't really know much going into it. And lastly, Noah Veltman. He's not an Android developer, but he's I think he works at NPR? Yeah, NPR. And he does a lot of work with path morphing on the web. He has a really cool talk called Pulling a Polygon Out of a Hat that I definitely recommend you check out if you're interested in this subject. And yeah, that's it. Here's my Twitter, Alex J. Lockwood, the slides, java.mp/pathmorph. And thanks.